this last video today, we're looking at what's happening here when the remnants of a supernova become a neutron star. So how do we end up here? Well, we've got to go all the way back up to the end of the main sequence. Now, if you have less than 1.4 solar masses, you're going to go this way, and you can't end up as a neutron star, you're going to end up as a white dwarf. But if you have more than 1.4 solar masses, you can go this way. Okay, so what, and that number, very importantly, is called the Chandrasekhar limit. Now, why does how much mass you have matter? Because when you become a neutron star, you've collapsed so much that the pressure is so high that it's actually high enough to force electrons into protons. It basically pushes electrons into protons. A better way to say that is it forces them to interact. It's the process of electron capture. And that makes neutrons. So that's why neutron stars are composed entirely of neutrons, because the huge pressure in one was enough to force all the electrons into the protons and turn them into neutrons. Now, we say that the pressure is high enough to overcome electron degeneracy pressure. So that's another phrase that you need to remember. But what on earth does that mean? Well, we're in the realms of quantum mechanics now. Basically, there's something called the Pauli exclusion principle, which says that no two electrons can be in exactly the same state. And so the only way to get electrons closer to protons, because you're not allowed to push them all down into the bottom energy level, so the only way to do it is for them to react with the protons. And so that's what's going on there. Okay, you don't need a really thorough understanding of that. But what you do need to be able to say is that if a star has more than this mass, which is called the Chandrasekhar limit, then electron degeneracy pressure will be overcome and the supernova, the star, will turn into a neutron star. Okay, one extra thing to add there. It doesn't have to, because it could turn into a black hole. And so there is another limit there, which is called the Tolman-Oppenheimer-Volkov limit, this one. And if you've got more than that mass, then you're going to end up as a black hole. But you don't need to remember the name of that one. Okay, here is a question. The most common questions on this ask you to explain why a star has become a neutron star or why it doesn't become a neutron star. But here's one with a slightly different take. So there's number 5, last question for today. Okay, all of these are the leftover insides of a star when outer layers have either been chucked out or drifted off. None of them are the main sequence. And then, if you have less than the Chandrasekhar limit, you're going to become a white dwarf. And if you've got more than that other limit with the long name, you're going to become a black hole. There we go.